Hi, in this video I will teach you how to write an equation for a plane, what kind of information you need, and then how you can use those information to write different forms of equations for a given plane. To write an equation, for a plane in R3, we need two pieces of information. One, it's called a normal vector. So we usually denote it by n, and since it is a vector in R3, it will have three components. Is a vector which is perpendicular to all directed line segments on the plane. It means what? Means that if you have a plane here, for any 2-point PQ, you can have a directed line segment. Transfer that directed line segment to a vector. So it will be, well, let's say this guy. And that guy, let us just write u, that u is always perpendicular to the vector n. So if you dot product, you get 0, or sometimes or most of the time you will see me drawing normal vector on the plane, just to giving you that idea that's perpendicular. So that's one piece. The second piece you need is a point on the plane. Doesn't matter. Every plane has infinitely many points. Any given point which will have three coordinates will work here. Okay, someone now gives you the point, a point and a normal vector, how to write the equation. Well, the key point is basically the definition of the normal vector. So if this is the normal vector, and if this is P, I'm drawing so that normal vector starts from P, but it is vector, so it starts from the origin. Then any other point X on the plane will give you the directed line segment PX. Yes, the directed line segment has an equivalent vector, which would be, so the equivalent vector to PX. Remember the end point minus the starting point. That is that. And by the definition of the normal vector, we know that n is perpendicular to x minus p. See, I'm changing x, which was a point, and p, which was a point, to a vector, just to make sense of the subtraction and being orthogonal. And the orthogonality test says that two vectors are orthogonal. If you dot product those two vectors, you get 0 vector. And that is exactly how you find the equation for the plane. In other words, this gives you an equation. It's called point normal form equation. It is basically n dot x minus, oh, this is minus p equals to 0, where n is n1, n2, n3. X is any point on the plane. In other words, you're looking for you have to kind of arrange your variables of the equation in that point x, and then p is p1, p2, p3. This is equal to 0. Well, that is how you find an equation. It's called point normal form for the given vector with normal and a given point. Well, let's do an example here. Example, find an equation in point normal form for the plane through the point P, which is 1, -2, and -3, and perpendicular to vector 2, 1, -1. Any equation given, you have to look for those two pieces. What is the given normal vector? In this case, it is 2, 1, and -1. And what is the point, the given point? This is this. The form we are looking is point normal, so you just write 2, 1, -1 dot. X is always x, y, z minus point is 1, -2, -3. This needs to be equal to 0. And that is how you find that equation. But you can do a little bit more on this. Note that we can kind of simplify this thing. You have n dot x minus p equal to 0, and then you can expand dot product over the subtraction, so you get n dot x minus n dot p equals to 0. And then you can take this to the other side and it will turn to the positive. N dot x needs to be equal to n dot p. And for the above example, for example, it will be 2, 1, -1 dot x is x, y, z equals to 2, 1, -1 dot 1, -2, -3. And then if we perform the dot product, there are actually two dot products. On each side there's one. So this will be 2 times x, 1 times y, and -1 times z. Then add them. This is the left hand side. The right hand side is 2 times 1 plus 1 times -2 and plus -1 times -3. What you find here is 2x plus y minus z equals to, this cancels with that, there will be just 3 there. You see, this is again an equation which describes exactly same plane, but its form is different. And this form actually has a name. It's called standard form. It is always a number multiplied x, b times y plus c times z equals a number. And let me just put this in a box. This form is called the standard form. You have to know the form, but there is two things to remember. Remark one is that to get the standard form, standard form, we expanded or we performed dot product in equation n dot x equals to n dot p. When you expand it, so basically n1 times x plus n2 times y plus n3 times z is equal to n1 times p1 plus n2 times p2 plus n3 times p3. The right hand side, both of them are numbers, so they will add up to one number d, and the coefficient of x, y, z are exactly the normal, the coordinates or components of the normal vector. And that brings us to the second remark. If an equation in the standard form for a plane is given, so I have ax plus by plus cz equals to d, then the coefficients of x, y, and z exactly form a normal vector. Then the vector given by, well, pick the coefficient of x, put it first component, coefficient of b in the second, coefficient of z in the third, is a normal vector for the plane. So you can find a normal vector using the standard form. Just pick the coefficients of the x, y, z in the equation. Let's finish the video by an example. Example, find an equation in the standard form for a plane passing through the point P, let's just 1, 0, -1, and is parallel to a plane given by this equation, 2x minus y plus z is equal to -3. Oh, sorry, this is plus 3. Okay. Well, always remember you have to find two pieces, and a normal vector, p a point on the plane. In this case, p is given, but the normal vector we have to find. Well, means that we have to use this information to find the normal vector. Well, how can we use that? Okay, you have two planes. This is our plane, and there is a plane down there. This plane is 2x minus y plus z is equal to 3. These two are parallel. What does that mean in terms of the normal vector? If two planes are parallel, the normal of one of them is perpendicular to the other one. In other words, we can take the norm and any normal vector of 2x minus y plus z equal to 3 as our normal vector n. We are looking for normal vector n, yes? We can take any normal vector of this plane as our normal vector. But you see that we can find a normal vector using the standard form. This is 2, -1, 1. is a normal vector to this plane, and so we can use it as n. We had p, we found n, then start writing the equation in the standard by n times x equals to n times p. And that means that 2, negative 1, 1 dot x, y, z is equal to 2, negative 1, 1 dot 1, 0, negative 1. Okay, so this gives us 2x minus y plus z equals to 2, negative 1 plus 0 is times 0 is 0, and that means that we have the equation in the standard form. Make the right hand side just one number, which is 1, and here we go. You found an equation in the standard form for such a plane. So we had two forms of equation, how to find them, what kind of information we need, and what are the forms of these equations.